we've got our graph y equals f of x. Here, it's given to us in function notation, even though you might look at it and say, I know what graph that is, because that's one of the graphs that we studied. But this whole question is in function notation. It says, sketch the graph of y equals -1/4 f of x. State the domain and range. So the first thing we're going to look at here in this equation that -1/4 is outside. That means it's going to be vertical. You're going to multiply your y values by -1/4. So when I go to actually draw the graph, I'm going to choose some points on my red graph. One of the points that I'm going to choose for sure, right, on an absolute value, that pointy point, it's not really a vertex, but it's kind of like a vertex. That's a very important point for this graph. We want to know where that point goes. Okay? Well, that point is 0, 0. If I took 0, 0, I drew my arrow and I said I want to multiply my y values by -1/4, it's still going to be 0, 0. 0 times -1/4 is still 0. If I'm choosing another point on this graph, can you tell me one reason why I might not want to choose 1, 1 or 2, 2, but I might like 4, 4? What's nice? Like on this graph, I have 4, 4. I have 5, 5, 6, 6. Mathematically, what would be nice about choosing 4, 4? Yeah, you get a whole number when you multiply by -1/4, right? Because that's the same as dividing by 4. I'm going to get 4, -1. So I go to 4, I go to -1. Careful here with the scale because it goes by 2s. What also might be a nice number to use? 8, 8. And similarly, we might use some of the numbers on the other side too, like -4, 4 and -8, 8. Now, if we were going to describe what has happened, we would say this is a vertical compression because it's been squished by a factor of 1/4. We always say by a factor of to show what we multiplied by. And notice how I didn't include the negative there? Because the negative is a vertical reflection. Finally, last sentence, state the domain and range of each function. So for the red one, I'm going to use the interval notation this time. The x values are everything. So I could have done xer, but I'm going to do -infinity to infinity. For the red graph, the smallest y value is 0, and it goes up forever. So I write square bracket 0 to infinity. for my blue graph, again, the domain is still everything, but the range has no smallest value, but it goes up to 0. This question was in function notation. It could have been a little bit more difficult if the question looked like this. Graph y equals -1/4 absolute value of x. Right? Our red graph was the absolute value of x. And what did we have? We had a -1/4 in front of it. Can you see that this is the same thing, but instead of having the function notation, which had f of x here, we have the actual equation, which is the absolute value. If you had this question, you would have to say, first of all, I can quickly graph the red graph. I know what points are on there. I know what shape it is. And then I could take points and see what happens to them. In this case, the y coordinates are multiplied by -1/4. Then draw your graph afterwards. So sometimes you're going to get questions where they give you no graph to begin with and just say you have to know what the absolute value graph is and go from there. And sometimes they'll give it to you in function notation, say, here's the graph, draw the next graph. Okay, try number 3. That was a long intro.